Hey guys, and welcome to 5.4. We're talking about complex numbers. We did this last year, or you did it in Algebra 1, even if you didn't do it with me. Quick review. First, we talked about the imaginary number. The imaginary numbers are numbers that don't really exist in reality. I don't know why we're learning about them, but we do. The symbol is I, and I is square root of -1. That's the value of I. The next value that I told you always want to remember and memorize is I squared, which kind of makes sense. If I would square this, that means I would have to square the square root. When I square the square root, this will cancel the square root and end up with the imaginary number squared will be the value of -1. It is the only number that when you square it, you get a negative value. Other than that, no number can be squared and get a negative. Now, those were the imaginary numbers we learned about last year. This year, we're talking about something called complex numbers. And complex numbers are not difficult, are just a mixture of real numbers and imaginary numbers. They look like this, a plus bi, or, for example, 2 plus 3i. That would be a complex number. You have a real number, which is 2, then you have the imaginary number 3i. It could be -5i, it could be just I. But this makes it a complex number. It's a mixture of the two, right? So, how do we solve stuff like that? Well, if I would tell you, what is square root of -5? Up until we learned about the imaginary numbers, this could have not been done because no number to the second power will give me -5. However, I can rewrite this as square root of -1 times 5, and we just learned in 5.3 that now I can separate them. This becomes square root of -1 times square root of 5. Oh, square root of -1 is I. This becomes I square root of 5. Okay, now you don't have to go through all the steps. Really, my advice for you would be as soon as you see square root of -5, think about this negative being an I got rid of the negative, is square root of 5, right? That negative represents the I. It comes outside, everything else stays in. Now, if I would have to do I square root of 5, and I square it all, this goes back to Algebra 1, right? This becomes a distribution factor. This becomes I squared times square root of 5 all squared. This is easy. That goes away with this. This is also easy. We just talked about it. I squared has a value of -1. -1 times 5 gives me -5. Okay? This is how you work. Just remember this. You want to memorize. Always make sure you know I squared is -1. Now, how do we use this in a math context? We really don't in real life because we don't work with imaginary numbers. But let's say we solve this. Solve 3x squared plus 10 equals -26. 3x squared plus 10 equals -26. I move my 10 on the other side. 3x squared equals -36 because I have to minus it to get rid of it. 36. I divide by 3. X squared equals -12. In a real life situation before 5.4, this would have been no solution. No number to the second power is -12. We're learning about complex numbers. We're going to do what we normally do. We take the square roots. This goes with that. I get an x equals square root of -12. We said, as soon as you see that negative, you think I root 12. Please do not stop here. That can be simplified. You have to make sure that number in there cannot be simplified. This becomes I square root of 4 times 3. Square root of 4 is 2, so this becomes 2i square root of 3. The other way to solve this would have been to say this is I square root of 2 times 2 times 3. Again, I have two 2's, one can come out, 2i, the 3 stays inside. Either way you solve it, this is faster because if you just think of 12 being 4 times 3, where 4 is a perfect square, you just move on faster, okay? But that's how we solve this stuff. Okay, so if you remember when we learned about all of the numbers, if you look on the bottom, by the way, we're on page 272. We have the real numbers, then we have the imaginary numbers, or the complex number, they look like that. And then we have the pure imaginary numbers, which is it just has an I, it doesn't have. So complex number has a real number and imaginary number. An imaginary number is just this, 5i, -3i, there's no real number in it, okay? Now, believe it or not, they can be also graphed and plotted. If I would make the thing like this, and I'm not going to spend a lot of time in here. This becomes your I. This becomes your, I think they call it a real, your R, right? If I would have to plot 3 minus 2I, did I just flip this? Yeah. I sometimes think I suffer of dyslexia. 2 minus 3I. How do I plot this? Well, this is going to be very easy. Let's do the first one. Where is my real number 2? 1, 2. Where's my imaginary number negative 3? 1, 2, 3. Negative 3I. This is the 2. It's the exact same thing. So you plot this number, and you make them meet. I'm going to do one more and then we're done. If I just say plot 4I, because it's going to be confusing a lot at times, this is just for I. You can even literally say 0 plus if you need to. Where my real number is 0, my other one is 1, 2, 3, 4. This is my 4I. This is my 4I, right? That's how we plot them. You can play with them as much as you want. You might have to, figure out, but it's just like the other ones. You plot that on your real, you plot that on your imaginary, and then you do just like you do on X and Y wherever they meet. Now, we're going to talk a little bit about addition, subtraction, multiplication, and division of complex numbers. The first 3, not that difficult. Division, a little bit different. Let's do 4 minus I in parentheses plus 3 plus 2I. Like this. The way we add complex numbers, we do real numbers with real numbers and imaginary numbers with imaginary numbers. 3 plus 4, 7, negative I plus 2I plus 1I, or just I, whatever you want to call it, right? So you go reals with reals, imaginary with imaginary. Let's do a subtraction now. 7 minus 5I minus 1 minus 5I, 1 minus 5I. If you remember, I told you before that you can either continue like this, or you can make this an addition, because we know how to add, but that means I have to change all of the signs in the parentheses, okay? I can make an addition, and then go inside my parentheses, and each term gets their sign changed. And now I just add, right? 7 plus negative 1, 6, negative 5I plus 5I, I get a 6, or plus 0, which is 6. Negative 5I plus 5I is 0. They're opposite, right? Let's try another one. What if we have 6 minus parentheses, negative 2 plus 9I, and then plus, this is just a little bit longer, negative 8 plus 4I, negative 8 plus 4I. This is a longer one. The first thing I want to get rid of is this minus, because it's going to confuse me. So I can make this a plus, that a plus, this becomes a minus. Everything changes sign. And now I'm good to go, because everything is addition, right? 6 plus 2, 8, plus negative 8, 0. Negative 9I plus 4I minus 4I, or negative 5I, right? The other way to go on this, I'm just trying to make it shorter for you. The other way would have been to do 6 plus 2 minus 8. These are all of your reals, plus negative 9I plus 4I. You can group them and go from there. That's exactly what we did. We don't need to do it that way. Multiplying gets a little bit tricky, but not hard. I erased that one. I'm going to put it back up here. Please remember this. I squared is negative 1. You're going to have to replace this a lot when we multiply. Let's do the first one. 5I times negative 2 plus I. This is just like I would be x. We're just going to distribute, right? This becomes negative 10I plus 5. I times I gives me an I squared. This is where you don't stop. We know the value of I squared, right? We know it's negative 1. So this becomes negative 10I plus 5 times negative 1, or negative 10I minus 5. However, a complex number puts the real number first always, so we want to rearrange this as negative 5 minus 10I. You want to put them in the right order always. Remember we said it's A plus BI. Your real number comes first. Please remember to flip them. So, key, I squared is negative 1. You replace it, and then it's just pure math. Let's try another one. 7 minus 4I times negative 1 plus 2I. Well, this is FOIL. It works just like FOIL. I'm trying to stay in the camera. It just works just like FOIL. So this is 7 times negative 1, negative 7. 7 times 2i plus 14i. Negative 4i times negative 1 plus 4i. And negative 4i times a positive 2i, negative 8. This is what you don't want to miss. I squared, right? It's an I times another I. Okay, let's group and also replace. Negative 7 stays negative 7. Positive 14 plus 4 plus 18i. Minus 8 times negative 1. Why? I squared is negative 1. This becomes a positive 8. 8 plus 7. 8 plus negative 7 gives me 1 plus 18i. Okay, that's where we are. There's one more example in the book. I'm going to let you look at it on your own so we don't make this video another 20 minutes. They all work the same, okay? The third example has that formula, a plus b, a minus b. If you don't want to, or you can't memorize the formula, you just do FOIL, you get to the exact same result. We are going to talk about dividing complex numbers, and they're not hard to do, or solving it in a standard form. 5 plus 3i over 1 minus 2i, I believe it is, yeah. In order to have this written in a way that mathematics accept it, you cannot have an I on the bottom. Okay, you cannot have a complex number on the bottom of a fraction. In order to get rid of it, I will have to times it by its, what do they call it? I want to make sure, conjugate. Okay, the conjugate of this number is the exact same number with the different sign in the middle. 1 and 2i, but now with a plus. Okay, and that's its conjugate. If I do it on the bottom, when I put parentheses, I have to do the same thing on the top to maintain the equality. So whatever I time on the bottom, I have to times on the top. Okay, this is the conjugate. On the top, we do FOIL. 5 times 1, 5. First, 5 times 2i plus 10i plus 3i, 3i times 1, and plus 6i squared. Please do not forget that. I squared equals 1, negative 1. Let's remember that. The bottom, you can do FOIL if you don't want to remember the formula. But remember, this is also a squared, as in 1 squared, minus b squared, 2i all squared. Okay? If I will be to do FOIL, I can get 1 plus 2i minus 2i minus 4i squared. Right? 1 plus 2i minus 2i minus 4i squared. Let's group the top and replace that. This becomes 5 plus 13i minus 6, right? I squared is negative 1. The bottom, they go away. I get 1 minus 4 times negative 1, right? Because I squared is negative 1. The top becomes 5 minus 6, negative 1 plus 13i. The bottom, 1 plus 4, 5. So you have 1 plus 13i, negative 1 plus 13i over 5. They wrote it in the book as negative 1 over 5 plus 13i over 5. I don't need you to write that way unless you really want to. You write it that way because you want to look at like a plus bi, right? So you separated it. If you just leave it like this, I don't mind you doing that way. The last thing we're going to, so before I jump to the next one, in order to get rid of whatever's on the bottom, you're going to time it by its conjugate. Remember, the conjugate is the exact same terms. The sign in the middle changes. So if this would have been a plus, then that would have become a minus. And whatever you times on the bottom as a conjugate, you have to times the exact same thing on the top to maintain equality. Now, the last thing we're going to do, we're skipping one part of this lesson because it's absolutely useless, is we are going to learn how to find absolute values of complex numbers. And remember, we said a complex number looked like this. A plus bi, as in 2 plus 3i. Okay. To find the absolute value of that complex number, it is square root of a squared plus b squared. You just take the two numbers in front of it and find the absolute value. So if I would just play with this one, and I'll do another example from the book. If my number is 2 plus 3i, and I want to know what is the absolute value of that, it becomes square root of 2 squared plus 3 squared. or square root of 4 plus 9, square root of 13. This cannot be reduced in any way. We're done. Let's try another one. What if I have 3 plus 4i? Well, this becomes absolute value of that number is 3 squared plus 4 squared, or I like this one, 9 plus 16, square root of 25, which is 5. Why don't I do plus or minus 5? This is an absolute value. We cannot have an absolute value be a negative number. Let's try another one just so you don't get confused. What if we get absolute value of negative 2i? If you get confused, remember you can put a 0 in front of it. Okay, and that way you know your a is 0. You don't have to worry about it. Absolute value of z becomes square root of 0 squared plus negative 2 squared, or square root of 0 plus 4, which is 4. Square root of 4 is 2. And that's how you play this, okay? You go over and over and over again, and you get these values out. If you can't solve it, you can leave it like this or do a decimal. The book did a decimal. I don't know why. I don't care about decimal. You can just leave it like this or write down my decimal. Either way of you would work just fine, okay? That's how you get this done. Now, on page 276 talks about Mandelbrot set. We're not going to worry about it. You will never use that. So this is where we end. You do not have homework from example 7, so nothing should be hard for you to do. Happy homework.